Welcome to topic number 28, solving exponential and logarithmic equations. Okay, so here are some of the techniques. Okay, so this is almost like, refresh your memory a little bit on how we can solve exponential equations. Okay, one of the things we already learned is this thing called base exponent property, which is if I can make my base the same, if I having an actual exponential equation, right? If I can make the base the same, I'm going to make the base the same. So I can set the exponent equal to each other, solve for my variable. Okay. If I cannot make my base the same, another thing I can also do is take a logarithm on both sides. That's mainly designed for the equation only consists of two terms. Or I can take a natural log on both sides. Or the only time I will take a natural log on both sides if I'm using a base e in my problem. Okay. Then I will take a natural log on both sides. If I'm using other bases than e, then I will take a logarithm on both sides. And yet again, remember, the the second and third technique is really designed for two terms only problems. Okay, so perfect example right here. E to the x equal to 5.8. All right, this is only two terms. So to solve for x, I cannot make 5.8 into a base e. So the only thing I can do is take a natural log on both sides, because if I can take a natural log on both sides, then the natural log and this e will cancel out. Then I just end up with x equals natural log of 5.8. All right. So this is called an exact answer. Write an exact answer and round the answer to four decimal places. So this is an exact answer, and I'm gonna put it in the calculator to get my decimal approximation. 1.7579. Okay, so that's all we do for this problem. This is a really simple problem. All right, this one on the right. Okay, right now I got three terms. -3 is like 10 with AO3, so I'm gonna move this over. So I get 2 times e to the 2x minus 5 is equal to 806. All right, before I take a natural log on both sides to cancel out the e, I want to divide both terms by 2, get rid of this coefficient. All right, I get e to the 2x minus 5 equals, all right, 403. Now I'm ready to take a natural log on both sides, so my e can cancel. So the left side, I have 2x minus 5, be careful here, equal to natural log of 403. Okay, so the 403 belongs to the natural log. To get x by itself, I need to move the -5 over. So that's 2x equal to natural log of 403 minus 5. So the 403 belongs to the natural log. The -5 do not. Okay, that's why sometimes people put a parenthesis right here. All right, we can do it too. So I basically have two terms on the right. To get x by itself, I divide every term by 2. So my final answer should be x equals natural log of 403 minus 5, both terms divided by 2. Okay, let me show you how to put it in the calculator. All right, I got two terms on top, right? Be careful, okay? Two terms on top. I'm going to go ahead and do those two terms. Natural log of 403, right? Close parenthesis, minus 5. Figure that out, then divide it by 2. 0.4995. 0.4995. I figure out those two terms first and then divide it by 2. So I don't have to use extra parentheses. All right, this example. 4 to the 2x minus 8 equal to 17. There's no way I can actually make the base the same. All right. So if I cannot make the base the same, what do I do? Well, since I don't, so here the only thing I can do is take a log on both sides. I'm not taking natural log because natural log, I use natural log to cancel out, when I'm using a base E. If I'm not using base E, I just take a log on both sides. All right. So if I want to take a log on both sides, this is what it look like. Okay. Log of 4 to the 2x minus 8. So the question is, well, Mr. Chan, why do you take a log on both sides for? What's the point? Well, the power rule for logarithm. The power rule for logarithm says if you have an exponent, if you take a logarithm of something with an exponent, those exponent automatically come to the front, come down to the front of your logarithm. That's why we take a log on both sides. So I can have 2x minus 8, right? Two terms go up front times log of 4 is equal to log of 17. This is multiplication now. It's multiplication. All right, bring the exponent down, basically. So now to get to x, right? To get to x, this is a little bit, there's a little bit of work. What I need to do is divide both sides. Rather than distribute log of 4 will give me more log, than I might want to. But I can. Yeah, let's go ahead and do that. It's 2 different weekends, right? Let's do that. I want to do it divided by the log, but then I'm thinking, okay, there's a two in front of x that might make this answer a little bit too ugly. All right, so if I distribute the log, that will be 2x times log of 4 minus, okay, the 8 cannot go behind the 4 because it's log of 4 times 8. So 8 goes in the front. That's log 8 times log of 4 equal to log of 17. So now I got 3 terms. This is my variable term. I'm gonna let it stay on that side. Okay. So move this term over. That's 2x times log of 4 equals log of 17 minus 8 times log of 4. All right. Now, this is the variable term. This is the variable term. X is the variable. So the 2 and log of 4 are coefficients. So now all I gotta do is divide all 3 terms by the coefficient. Then I get x equals log of 17 minus 8 times log of 4 over 2 log of 4. There you go. Excuse me. All right, this is a little bit messy, okay? This is a little bit messy. I'm gonna do the top first. Log of 17 minus 8 times log of 4. Figure that out. Then divided by parenthesis. I'm gonna put parenthesis 2 times log. I want the whole entire top divided by this entire bottom. That's why I put 2 times log of 4 in the parenthesis. So the calculator will do 2 times log of 4 and then negative 3.5 something will divide. All right, negative 2.9781. There you go. That's how we do that problem. All right. Take a log on both sides so the exponent can come down. Once the exponent is down, I distribute my log. Find out I only got one variable term, so I can start moving term to the other side, divided by the coefficients. All right, now this particular example here on the right, I have there's an e there, so I can take a natural log on both sides. All right, so if I take a natural log on both sides, I'm gonna write it down, okay? I'm gonna write it out for you. If I take a natural log on both sides, that will look like natural log of 5e 3x plus 2, 12, equal to natural log of 4 to the 3x minus 5. Well, the purpose of taking natural log, again, just like similar to taking a log on both sides, is about the exponents, okay? It's about the exponents. But right now, be very careful. This 3x plus 12 is the exponent for the e, not for the 5. So natural log of 5 times e to the something, right? There's a multiplication right here. So here I can actually expand, I can actually expand 5 times e to the 3x using the product rule that allow me to say this is natural log of 5 plus natural log, oops, e to the 3x plus 12. So taking the natural log on both sides allow my exponent to come down, right? But the exponent is only on top of the e. That's the reason why I still have to expand this natural log, expand this term into two different terms. So now this exponent and that exponent will go to the front of its respective term. So I end up with natural log of 5 plus 3. Oh, well, as a matter of fact, is a natural log and e cancels out. So only thing I end up with is just 3x plus 12 right there. Equals, this goes to the front. This doesn't cancel right here. So this goes in the front. That's 3x over 5 times natural log of 4. All right. So now I got 1, 2, 3, 4. I got 4 terms. This term contains the variable x. This term contains the variable x. So they need to be on the same side of the equal sign. So what I'm going to do is move this term to this side. So that gave me natural log of 5 plus 12, right? The 5 belongs to natural log, okay? The plus 12 is two separate term, equals 3x over 5 times natural log of 4 minus 3x. The reason why I want the x's to be on the same side so that these two terms, I can factor out the x. I can actually factor out the x, not 3x. I just want to factor out the x because I want x by itself. If I factor out x only, that gave me 3 over 5, right? Natural log of 4 minus 3 equals natural log of 5 plus 12. Now I can divide both sides by my coefficient. Ooh, move it too much. All right, so my final answer, x is actually equal to natural log of 5 plus 12 over 3 over 5 natural log of 4 minus 3. All right, that will be my exact answer. Let me bring it down a little bit. I can rewrite this, that's okay. Kind of ugly looking answer, but that's okay. All right. Let's try another ones. Do a little bit more space, okay? All right. Let's try this one, okay? Two terms only. So I'm going to take a natural log. So when I take a natural log here, okay, this is a little bit different than the previous example. The previous example, when I take a natural log earlier, it's actually 5 times something, right? 5 times e to the something. So the natural log and e cannot cancel right away because you got a 5 right in front of the e. Right now, I don't have that. So here I can right away say natural log and e cancels out. The left side would just end up with 2x plus 3. The right side is natural log of 24 to the 2x plus 9. All right, this exponent cannot come down. So negative 2x plus 3 is now equal to 2x plus 9. Whole thing will times by, both of these terms is actually times natural log of 24. All right, distribute the natural log of 24. So that's negative 2x plus 3 equals 2x times natural log of 24 plus 9 times natural log of 24. All right, my variable term is negative 2x and 2x natural log of 24. This is positive here. I'm going to move the negative 2x over, move this term back. So if I move the negative 2x to the right, 2x natural log of 24 still there. Negative 2x come over, become positive. This term go over, that will be 3 minus 9 times natural log of 24. Again, factor out the x, like I did earlier. So then now I can divide both sides by what? I say both sides, even though there's two term on the other side, I just say both sides so you don't have to type so much. So now we can just divide both sides by the coefficient. So the x will equal to 3 minus 9 times natural log of 24 over 2 natural log of 24 plus 2. There you go. All right, this question on the right, we'll do exactly the same way. Take a natural log on both sides again. All right, natural log of e cancels out. That's 3x plus 9 equals natural log of 47 ex plus 11. Okay, natural log of 47 ex to the plus 11. Now this exponent can come down to the front. So ex plus 11 times natural log of 47. Distribute the natural log of 47. All right, are you okay? I should get ex times natural log of 47 plus, remember now, e and natural log cancels out, right? E and natural log cancel out. But this right now, that's not what we're doing here. Gotta be very careful. This is not e, is not taking a natural log of that e. We're actually multiplying. So right now, they actually cannot cancel. So when we take a natural log on both sides, yeah, technically they can cancel, but this is actually a natural log of something else times e to the x, which is different than just taking a natural log on both sides. All right, the other side is nat 11 times natural log of 47. All right, once again, I'm going to move, this is my variable term. This is my variable term. I'm going to move the 3x over and move this term to the other side. So EX times natural log of 49 minus 3X, right? 3X come over to the right, become negative. 9 still 9. 11 natural log 47 come over, become negative. Factor the X. All right. Now I divide both sides by the coefficient. So it's a little bit of writing. Mathematically, it's mathematically it's not hard. It's just a lot of stuff we are writing. But the technique is not difficult. Where does 49 come from? 47. Oh Lord, I've been writing 49 all this time. It's 47 minus 3. There you go. That will be my exact answer. All right, to find a decimal approximation, if you want to find decimal approximation like these, then you might have to you might want to put the top in one parenthesis, the bottom in the other one. 11 times natural log of 47. Close it, right? Close one for the 47, close one for the numerator, divided by E. Now, this is tricky. This is not E raised into some sort of power. So the other place for the E is right above the division. So second E. That will allow you to say E times natural log of 47 minus 3. And close the parenthesis for the denominator. There you go. That's your decimal approximation. Negative 4.4673. Ooh, these are ugly. So both the example, do we take a natural log on both sides, right? One side, the E and the natural log cancels out. The other side, allow me to bring the exponent to the front. Why do I want to bring the exponent to the front? Because these variables are stuck on the exponents. In order for us to solve for X, they have to be what? They have to come down from the exponent in order for me to move terms and divide it by coefficients. All right. All right. So that's for exponential equation. Those are a little bit more complicated. Those type of exponential equations, you can never make the base the same. All right. Here I got solving on logarithmic equations. So I'm gonna do this as a second part of this topic. Okay. And then next time we will solve logarithmic equations and we'll go over the homework. Okay. These are not difficult, but they do require us to use these properties again. All right. So stay tuned for part 2.